Hi, welcome everybody. So today we're going to discuss limiting reagent problems. And so to do this, there's a strategy to figuring these out. But when you have a limiting reagent, what we're really talking about here is one of the reactants, or as we say in the lab, reagent, because that's what they call them, runs out. It gets used up. At that point, once we have a used up reactant, the reaction stops. We don't have any more reactants present, at least not all of them present. And so that is a problem. And so how do we figure this out? Well, let's take a reaction. 2H2 plus O2 yields 2H2O. And let's say that you're given the following information. Let's say that you're given 8 moles of H2, and you're given 2 moles of O2. Actually, you know what? Let's do 8 moles of H2 and let's do 10 moles of O2, just to sort of make it more fun. Now, this is a departure from what we've seen before, because in this case, what's going on is we're given both moles of both reactants. Normally, they would say one was excess, so they're telling you which one is excess and which one's limiting. Remember, the excess one we disregarded because we don't really care about it. We have excess. Here we have to figure out which one is limiting and use that to find the product. Now there's different ways of doing this. One way I'm going to show you is to just test both out. That's really the easiest way to do it. So let's say that we want to figure out how many moles of H2O we're going to form. Well, let's test both reactants out. 8 moles of H2 times, well, for every 2 H2O, we are going to form, or we're going to use 2H2. So in this case, we will form 8 moles of H2O. This is answer 1. But we have to test out O2 also, because if we don't test out O2, we won't know which one's limiting. So let's test that out. 10 moles of O2 times, well, for every 2 H2Os, we are going to have 1 O2, and so we'll make 20 moles of H2O. So we have 2 answers here, answer 1, answer 2. Only one of them is correct, though. We got to figure out which one is correct. The answer to that is always the following: whichever one gives us the least. This is the correct answer. This one down here is not correct. So the correct answer is the lesser answer, the one that you make less of. Now, why is that the case? Well, if you make less of something, you're making less H2O. That's because the H2 ran out. So what that tells us is that this 8 moles of H2, this is my limiting factor, my limiting reagent. My O2 is excess. Well, how much excess did I have left over? You know, how much O2 did I have remaining? So at this point, we figured out, well, we have 8 moles of H2O formed. How much excess O2 is left? So amount of excess O2. And again, there's many ways to do this. One way that, Mr. Casino and I were discussing and decided to go this route this year is to subtract the difference of the products. So if we take 20 minus 8, that's a difference of 12 moles of H2O. So that's 12 moles of H2O that are formed here. So now, how do I go about finding out how much O2 is left over? Well, I just do a ratio of them. 12 moles of H2O times 1 O2 for every 2 H2O. That will give us 6 moles of O2 remaining. And we're done. It's that simple. Now, I don't have to give you moles. I could give you grams. I could give you the grams of each one. And then you have to change it to moles and try and do it. So let me give you a practice problem to look at on your own, and we'll talk about it tomorrow. Let's say that you had, N2 plus 3H2 yields 2NH3. And let's say that I gave you, 28 grams of N2, and let's say that I gave you 10 grams of H2. In fact, you know something? Let's do this. Let's make this 56 grams, and let's keep that as 10 grams. So let's see if you can figure out which one's limiting, which one's excess, based on these numbers. So, and also how many grams of this form. So the first question is how many grams of NH3 form, and then, so how many grams of NH3 form, and secondly, how much excess. And I don't tell you which one's excess, you got to figure that out. What's the excess left over? So those are the two questions that we're gonna ask for this. Okay, that's the two types of questions that we're going to be asked. So that's limiting reagents. We'll practice a bunch of them in class, but you got to go through and do the same problems we've been doing before, except now we do them twice. We see which one's less, that's the correct answer. We subtract the two answers, we find the difference in the moles of the product, we work backwards to find out how many moles remain. The last thing that I want to talk to you about for this video is percent yield. And percent yield is equal to the actual yield over the theoretical yield times 100. So actual yield, that is how much you actually make. This is in the lab. The theoretical yield, on the other end, this is how much you get from a calculation. So if we look back at our last problem, we had a theoretical yield where we did the H2O. We had a theoretical yield of 8 moles. So we had H2O where we formed 8 moles of H2O. That's what we theoretically had. But, let's say in the lab, let's say that, for example, we form 6 moles. So now we want to find the percent yield. Well, we have the 6 moles that we have in the lab over the 8 moles total times 100. That will give us 75%. And again, we'll practice more of these going forward, but this is the basis for these two ideas. Know these equations for percent yield, and we'll go from there. All right, thanks so much for watching.